Hello friends, we know matter has a different composition. The composition of matters differ from one another. The composition of matter can be studied, can be known by different techniques. That is called spectroscopy. This technique helps to identify the composition of particular substance. What are the elements present in the compound? What are the structure of the compound can be known by spectroscopy. So many spectroscopic techniques are being used in science. These are IR, that is infrared spectroscopy, and ultraviolet spectroscopy, X-ray, NMR, scanning electron microscopy, like so many, NMR. So many techniques are being used in spectroscopy to study the composition of substance, to study the properties of substance, to study the structure of the compound. So today we will discuss very interesting topic, that is spectra. Spectra, it is a singular term and the plural is spectra is the plural term and the singular term is spectrum, and it is mainly observed by technique is called spectroscopy and the instrument is called spectroscope. Instrument is called spectroscope. The spectroscope mainly, when light pass through the substance, it produces from substance, this is the source of light, and passing through the small hole, then fall on the prism. We know prism helps to disperse the light. It divides the light into different monochromatic form, and this light will fall on the screen, that is spectrophotometer, that is a screen which identifies the radiation produced. When it falls on the screen, it gives illumination, it gives light. So if you take white light, that is solar light, if you pass through the prism, fall on the prism, then different colors of light What are these? 7 colors: violet, blue, green, then orange, yellow, red. So like this, 7 color of lights are produced on the screen, and this arrangement, increasing order of wavelength, Vigor, increasing order of violet, indigo, Vigor, GYUR. Okay, like this. So these 7 colors produced, it has arranged in definite order, that is increasing order of wavelength. And this is called what? Spectroscopy. This arrangement, that is called spectrum. Generally it is called spectrum. Spectrum. Spectrum means arranging the different lights in increasing order of wavelength or decreasing order of frequency. Increasing order of wavelength means decreasing order of frequency. This is called spectrum, and this is called spectrophotometer, and the instrument is called spectroscope, and the technique is called spectroscopy. That is called spectroscopy. So many types of spectroscopy already I have told you. IR, UV, X-ray, then NMR. These are the some important techniques, spectroscopic techniques used to study the composition of substance, composition of matter. Generally, there are two types of spectroscopy. Spectroscopy generally two types. One is emission spectroscopy. Emission spectroscopy. Second one is absorption spectroscopy. There are two types, emission and absorption, and they have different characteristics. Emission spectroscopy and your absorption spectroscopy, they have different characteristics. In emission spectroscopy, it is generally observed when excited substance emit light. Radiation from excited substance. That means when the substance will be heated or it will be electrically charged, it should be excited. When it will be excited, this excited substance produces light. It produces, after observing, it produces light. That light is called emission spectroscopy. Radiation from excited substance, that means heated either electrically or thermally. When it will be heated, it will produce light. That light is called emission spectroscopy, emission spectra. And the light observed in the photometer, in what way? That bright light with dark space. How it is obtained? Obtained in the photometer as, what is the characteristic? As bright light, bright color light with dark space. What is this? What is the characteristic of emission spectra? That is obtained in the form of what? Bright lines, bright color light, bright lines, bright color lines, light with dark space. That means it is observed like this. If it is the photometer, when light falls, it will be some, this is your whole light, it will be dark, then some light will be observed like this. bright light with dark space. These are the dark space. Like this. Brighter lines are produced. These are the brighter lines obtained on the screen in the photographic screen in photometer. That is the important characteristic of emission spectra, and it is also called as continuous spectra. It is continuous spectra. This is another characteristic. It is called continuous spectra. Which one? Emission spectra is a continuous spectra, and what are the characteristic? The characteristic is bright lines with a dark space. With dark space, and it is produced from excited substance, and this is also called as line spectra. It is called as line spectra. This emission spectra is called line spectra, or it is called atomic spectra. Because different atoms in the compound has different line spectra. If the atoms are different, then different line spectra are produced. Suppose sodium chloride. Sodium chloride, if you study the sodium chloride, if you heated the sodium chloride, then you produce brighter two yellow lines produced. That yellow lines, suppose you take sodium. Observe the light heated. When you heat sodium vapor, the light produced from sodium vapor after heating, when the light produced from sodium vapor will be allowed to pass through the prism, and when all lights after passing through prism fall on the what? Photometer, that is screen, photographic screen, then it observe some yellow lines. That yellow lines observed due to emission of sodium metal. Sodium metal generally produce two bright lines, that is 590, another is 596 nanometer. This yellow, these are yellow lines. Already we have discussed, bright lines means color lines are produced. Color lines are produced for sodium atom. These are two color lines, 590 nanometer and 596 nanometer. Like these two lines are produced. That's why it is called line spectra, continuous spectra, atomic spectra, and which is called fingerprint spectra. It is also called fingerprint spectra. Why it is called fingerprint spectra? Because different element has a different line spectra. No similarity. It differ from one another. That's why it is called fingerprint. Fingerprint spectra, line spectra, atomic spectra, continuous spectra, emission spectra, like this. These are the some important classification or characteristic of emission spectra. And it is obtained when the substance gets heated. When the substance gets heated. That means the vapor of substance will be heated, or any substance will be heated either thermally or electrically. It produces bright lines with the dark space. These are called emission spectra. Okay. Second spectra is, that is absorption spectra. absorption spectra just opposite of emission spectra. It is obtained, mainly it is obtained, the light radiation obtained after light, mainly white light, after light passing through the substance. That means here what is the difference here? In emission spectra, when the substance gets heated, that light produced from the excited substance directly used in the spectrophotometer, in the spectroscope. But in absorption spectra, the radiation obtained after light passing through the substance. That means you have to take the liquid or vapor of the substance. Suppose you take the substance here, then light will pass. This is white light. Then the light produced from the substance will be allowed through the prism. Then it will be passed on the photometer. Photograph screen. This is the characteristic. After light passing through the substance, then the light produced from the substance, that radiation will be studied. That is called your absorption spectra. Here what happens? Some light will be absorbed by the substance. The light, some particular wavelength of light will be absorbed by the substance. So what will be the nature? What will be the characteristic of this spectra? The characteristic is, here the characteristic is bright light with dark space. But here dark lines in continuous spectra. That means dark lines in continuous spectra means it is a discontinuous spectra. It is a discontinuous spectra. Because some light will be absorbed by the substance. When white light will be used, the light will be absorbed by the substance. That's why dark lines are obtained. That's why it will be discontinuous. So absorption spectra is called discontinuous spectra because due to absorption of the particular wavelength of light by the substance. But it is a continuous spectrum. Emission is continuous, it is discontinuous. Here nature is dark lines in the spectrum, but here bright lines with dark space. This is the difference of absorption spectra and emission spectra. And this spectra is same for the, for example, you take sodium chloride solution. Sodium chloride solution taken. Then you pass the white light. White light you allow to pass sodium chloride. Then the light after passing sodium chloride will be allowed to pass the prism. Then in the screen, what is obtained? It is obtained like this. What? Color light with dark space. Dark. Why? same, but what wavelength? 596 nanometer, and this is also 590 nanometer. At the same wavelength region, at the same wavelength, at the same place of photometer, dark lines are produced. Why it is become dark? Because why it is dark? Because this particular wavelength light is absorbed by sodium chloride. That's why dark space is dark lines are produced. Here bright lines are produced because directly the light is passing through the prism. No absorption takes place. No light will be hidden. Here the particular wavelength of light is hidden by the substance due to absorption. So this is the main characteristic of absorption spectra and emission spectra. And this is the main spectra which is used to study the what? Nature of element. The nature of element, the type of element can be studied by line spectra, that is emission spectra, by excited substance. So this is also very important to know the what? Which part of light is absorbed. From the photographic screen we can know what are the light, what are the substance present in the sample. Because the particular wavelength of light is absorbed. That is also, this is directly, this is indirectly. Direct the substance, the light is produced and observed in the screen. Here the light will be absorbed, then observed in the photograph screen, and it is observed as dark lines. This is the difference between emission spectra, absorption spectra in spectroscopy. So spectroscopy nowadays is very important to characterize the different samples. Any substance, any unknown substance is characterized by spectroscopy. By, already I have told you, infrared spectroscopy, ultraviolet spectroscopy, NMR spectroscopy. So many spectroscopy techniques are being used to study to identify the elements, the composition of the substance. Okay, thank you.